Factoring trinomials of the form ax squared plus bx plus c is what we're going to focus on here. The first case we look at is all the ones that start with a leading coefficient a equals 1. So the leading coefficient is always 1, and then b and c could be different constants. Then once we master that, we're going to move on to the trinomial starting with any value a. So what is our goal? We basically want to take the trinomial, whether it's in the easy case or the harder case, and we want to break it up into two binomials. In other words, we're kind of again undistributing and breaking it up in terms of simpler polynomials. In this case, the two parentheses will contain binomials that we're breaking this up into. So let's look at these two cases. We're going to factor these two starting with a leading coefficient 1. So this is examples of case 1 basically. So let's go ahead and say that's type 1 we're focusing on. Now again, my goal is to break this up into two binomials multiplied to give me this original trinomial. So I have to think of two things that multiply to give me x squared. Well, I'll always put x and x for those. And then how do these two play a role? I'm looking for two numbers that multiply to give me 6, and the exact same two numbers should add to give me the middle term 5. So the factors of 6 that work are 2 and 3 because they multiply to give me 6 and they add to give me 5. And I always pay attention to signs also. If everything is positive, all of them will remain positive and it's easier. So plus 2 plus 3 are the two factors that make it work. And again, whether you put the 3 first or the 2 first doesn't matter. Now I can check my work, and remember, checking your work simply means redistributing and seeing what you get. You get x squared plus 3x plus 2x plus 6, and that's gonna definitely simplify to my original polynomial or trinomial. So that's fully factored. I have a product of two binomials with each parentheses containing nothing more in common that I can pull out. Let's go to the next one. Again, leading coefficient 1 is always easier. So I'm going to put x and x to get the x squared. Then again, I think of two numbers or two factors of negative 10. Be careful about the negative 10. That multiply to give me negative 10, and those same two numbers add to give me 3. So the factors of 10 that pop up in my head are 2 and 5. But in order to make them a negative 10, one of them has to be negative. And in order for the sum to remain positive, the bigger one has to be positive. So I'm thinking 2 times negative 2 times 5 will give me the negative 10 I need. And then negative 2 plus 5 will give me the 3 I need in the middle. So both of these work. My two numbers are minus 2 and positive 5. And again, before I box my answer, I'm going to quickly check this. And we're going to get x squared plus 5x, then minus 2x, then minus 10, which is going to give me x squared plus the 3x I needed in the middle plus the 10. So that works out, and my trinomial is factored into these two binomials. Okay, part C again, I'm going to open up my two binomials, y and y. Two numbers to multiply to give me a negative 16. The same two must add to give me negative 6. So I just go through the factors of 16. The two numbers that have a difference of 6 are 2 and 8. But in order for it to be a negative 16 and multiply to be negative and add to remain negative, the bigger one has to be negative. So I'm thinking that's going to give me the negative 16 I need. And if I add them, I get the negative 6 I need. So the two factors are positive 2 and negative 8. And again, you can check your work if you want to by multiplying it out. Part D, I'm going to have z and z. And I'm looking for two numbers that multiply to a positive 15 but add to a negative 8. So if they multiply to be a positive 16, both of them have to be either positive or negative. But if they're adding to be negative, both of them better be negative. The two factors of 15 that come to mind are 3 and 5. And again, they must both be negative to give me a product that's positive and a sum that's negative. That's going to give me a positive 15 when multiplied and when added, it's going to give me the -8 I need. So -3 and -5 are the two numbers that work. And again, remember, the order doesn't matter, so if you have them the other way switched, that's okay too. Okay, next one, it looks like this is a little different because it starts off with a 2, but notice I have a GCF that's 2. So your first check should always be GCF. If there's a GCF, before you do anything else, pull out the GCF. All the other problems we did up above, they didn't have a GCF for me to pull out of any of these. But part E happens to have a GCF of 2, so I got to pull that and put it outside first. That's going to make it x squared plus 2x minus 24. Now that I have that, I can go ahead and just focus on this trinomial and then worry about the 2 later. So I'm going to open up my two parentheses. For the x squared, I'm going to put x and x. And then I'm looking for two numbers that multiply to -24 but add to a +2. And the factors that might work might be 6 and 4. But one of them has to be negative to give a -24. And it has to be the smaller one because the sum remains positive. So that gives me -24. But if I add those guys, I do get the +2 I need, so +6 and -4 win, and then don't forget to drop the 2 you pulled out at the very beginning. And that's fully factored. I pulled out the GCF, and each binomial is completely filtered out or factored out with nothing in common. Alright, now let's move on to the slightly harder case where the leading coefficient is no longer 1 and it's any value a. Now we're going to do this problem, these type of problems, especially the first example, 3 different ways, 3 methods. There's the trial and error method, there's the grouping method I'll show, and then the last one, which I have learned about recently, I'm just going to call that the wow method because chances are you've never seen that method before. So I'll just go ahead and call that the wow method. Let's start off by looking at this with the trial and error method. So we're going to analyze this one problem of factoring with the 3 methods slowly, and then from here on I'm going to mainly focus on this new wow method. So trial and error method says just open up your 2 binomials and start guessing how the thing is going to break up so that you can make the 7x in the middle turn out to be okay. So I'll say 2x squared, I'm going to guess, say 2x and x, because I know those guys multiply to give me 2x squared. And then I'll say, well, to get a 3 for the end, so you focus at the beginning, you focus at the end, and you hope that the middle works out nicely for you. Well, how do I get a 3? The factor of 3, the only 2 options I have are 3 and 1, so I'm just going to say a +3 and a +1. Again, it's called trial and error, so you're just trying this out to see what's going to happen. Now you're going to check to see if this really gives you the 7x in the middle. That's going to be 2x squared plus 2x plus 3x plus 3, and notice these guys give you 5x, which is a no. So this first 2 binomials I tried didn't work. Then I say, okay, 2x and 2x give me 2x squared. Let me put the +3 here and the +1 here. So I switched their locations and paired them up with the different numbers. I'm going to go ahead and distribute and check my work, but to get the middle term, remember all I got to do is check the outers multiplied and the inners multiplied. So those guys give me 6x, it looks like. And the middle terms give me 1x, which gives me the total of 7x, which is what I was looking for. So that actually factors correctly into what I needed. These 2 binomials give me back my original trinomial. And again, I did trial and error. My first try didn't work, my second try worked. Now, if the coefficients here and here were bigger, they had more factors, and the signs were different, then there would be more possibilities, and you may have had to have tried 3 or 4 different times before you get to the final answer. But nevertheless, be exposed to the idea of trial and error method, and you might like it and you might stick to it. Now, how does the grouping method work for the same problem? you connect these two guys and you say, okay, those two make a product of 6, and I'm gonna find two numbers that give me a product of 6 and a sum of 7. So you kind of play the number game like you did before with the leading coefficient 1 problems. And the reason I have these there is because I'm going to split open the 7 in terms of two other numbers that's going to satisfy this. So the product is going to be 6 and the sum is going to be 7. In other words, two things that multiply to give me 6 but add to give me 7. And those two numbers have to be 6 and 1. 6 times 1 gives me 6, and 6 plus 1 gives me 7. So I break open the middle term in terms of those two numbers. Once I break open the middle term in terms of those two numbers, now I can do grouping. So I took something that started with 3 terms, I changed it into 4 terms, I broke it up specifically so that I could do grouping nicely. Again, two numbers that multiply to 6 and give you 7 are going to be 6 and 1, so they have to be those numbers that'll make it work. You can't just split open the 7x as like a 2x and a 5x. That won't work. It has to be the distinct numbers that give you a product of 6, which I got from multiplying the two edges. So now GCF 2x, that leaves me with x plus 3, plus GCF just a 1, that leaves me with x plus 3. Now remember from before, they have the big binomial in common. So you're going to pull out this big binomial, put it out in the front. That's going to be x plus 3, and you're going to be left with these two guys, 2x plus 1, and lo and behold, we got the exact same thing we got doing this method, just the parentheses are in a different order, which is perfectly fine. Alright, on to the wow method. What's the wow method? You don't like the 2 in the front? You just say, I'm going to take it up and multiply it with the 3, and that's going to give me this new problem, x squared plus 7x plus 6. So I just completely made a new problem by pulling the 2 upstairs and multiplying it by the 3. Now I'm going to focus on factoring this guy, x and x, two numbers that multiply to give me 6 and add to 7, so it kind of becomes like these above problems here, where we're in our own little world, and now the leading coefficient is going to be just a 1. Two numbers that multiply to 6 and give you a 7 are positive 6 and positive 1. But clearly this can't be the answer because I had made that change in the original where I had kind of swallowed up the 2 and gotten rid of it. So since I multiplied by 2, I'm going to do this little thing of divide these two items by 2. And once I divide them by 2, I do any reducing that's possible. Any reducing that's possible. There is reducing possible here. 6 divided by 2 is 3. There is no reducing possible here. If there is no reducing possible, shove this guy back up. That's going to be 2x plus 1. So this method seems sort of like you're doing a bunch of illegal stuff. And maybe once you get to pre-calculus, you can kind of tell why this method works, but as of right now, it's really like a process you're really going through. It's not as intuitive as these two methods. It's kind of like going through, okay, I do this, then I do that, and I do that, and I get to the answer. So I call it the wow method because almost magically things work okay here. You take any problem that starts with a leading coefficient other than 1, you turn it into a new problem where you like it because the leading coefficient is now 1, you factor that new problem, and then you always divide by whatever you had moved up to multiply. Divide both sides by that, and then either reduce or move the fraction's denominator back up, and you're done. And notice you get the same answer as you did before.